Hello and welcome to a session on some grade 10 foundational math concepts where we're going to talk about some exponents perhaps, just laying that groundwork for when you're moving into algebra, the concepts that we can establish with numbers and integers transfer almost completely to algebra. But people get a little confused because they look at all the letters and the symbols and think they need to do different weird things when in fact it's exactly the same. When it comes to exponents, of course, the exponential notation is simply a short, convenient way to write repeated multiplication, and we can very easily do this one in our head. I'm using IXL to just generate some examples for us. Feel free to use that if you want to, totally up to you. 3 times 3 times 3 is therefore 27. So don't view exponents as anything weird, just repeated multiplication. This is 2 times 2 times 2, 3 times. That's our repeated multiplication. 2 times 2 is 4, 4 times 2 is 8. Let's run through these a little bit faster. This is 4 times 4 times 4. Repeated multiplication. 4 times 4 is 16. Let's do it like this. And so 16 times 4. Hopefully, you're at a point where you don't need a calculator for basic things like that. It is 64, but of course, as things get bigger, we have a calculator as an option for more convenience. We have already seen this one, 27. I'm speeding this up. It's the same question. I want to keep it up, but give me something new. There we go. So now we get into sort of the flipped version of exponents. Now I'm going to do this symbolically first to give you the rule or the property. Let's call it a property. I don't like the word rule. Now it looks as if my hand is super shaky. It's not, it's just the pen. That is all. So if I have, as long as I have the same base in an equation, let's call the base A. I know it's a lot of letters to establish a general property without being tied into specific numbers. If let's make this a little square, whatever this exponent is, and whatever that exponent is, as long as there's nothing else around, just a single base and the same base on either side of the equation, these two have to be the same. They have to be the same. And if two things are the same, it also goes the other way. Then, as long as it's the same base, those respective exponents have to equal each other as well. Now, there's a lot of symbols there, but we have to get used to it some time. No time like the present. So now, when I have 10 to the power of this mysterious u variable, and that's equal to 1,000, I can rewrite this so that it has the same base. In this case, it'll be 10 to the power of 3, and then conclude from this property that the exponents have to be the same. That is a key exponential property, and so u is a 3. We are correct. It becomes less obvious, perhaps, once there are more and more variables, but the same property is always there. Here we're just simplifying, and it's a different property. Let's write this property. Property in my very shaky pen. That if I have two things being multiplied, let's call it an A and let's call it a B. And they're first multiplied in the brackets and then raised to some square exponent. Little square symbol there. Then it is I can expand the bracket, the first one squared times the, not squared, it is a square, but it could be anything. And the second one, the b, also raised to that same power. So now when I have negative 3 to the power of 4, yes, I know I could do this in a simpler way. Negative 3 times negative 3 times negative 3 times negative, whoopsie, not 4. No. Back that up. Where's my undo button? No, I don't know. There's my undo button. More. There we go. Negative 3. And then I can reorganize and shuffle things around. Yes, but it's not going to be convenient for very long. So instead, I want to write this as negative 1 times 3, and my big bracket around that is to the power of 4. So then I have, by this property, negative 1 to the power of 4 times 3 to the power of 4. This negative 1 times itself, an even number of times will be 1. And this 3 to the power of 4 is easier to figure out now because it's a positive integer. That's 4 3's multiplied together. 3 times 3 is 9, times another 3 is 20. Let's tick them off. 3 times 3 is 9, times another 3 is 27, times another 3, 81. And so I can put in my answer as positive 81. Now, when the numbers get bigger and I have larger powers here, yeah, we'll cross over to a calculator for sure. No problem. These things happen eventually. Also, I just had here a very sort of, in a way, a trick question, it feels like. 0 times itself 3 times, still just 0. 0 times anything is 0. Now here, I'll call it a property of exponents, and I don't really want to get into why this is true right now. But if I take any number a, not 0, that is a different issue, to the power of 0, that will always be a 1. It doesn't matter if it's positive, it doesn't matter if it's a weird decimal number, does not matter at all. That'll be a 1. And you can think of it in simple terms as a rule to make exponents work with everything else when it comes to 0, because 0 is a slightly weird number, put simply. So now I'm looking at my property. Remember the property, if a to the power of something equals a to the power of seemingly something else, those two exponents must be the same, whatever symbol you want to use. So now to wrap things up, we'll do this one. So now I have 5, and my v is my variable in the exponent equals 1. I'm just copying this down. I need to write the other side if possible. It's not always possible, but for these it will always be. For this level, I have to write this as 5 to the power of something. And based on my previous experience, I know that 5 to the 0 will be 1. And now I have this situation over here, and I can conclude that the v has to be a 0. But it's important to know which properties I am using and I'm building on. There are a few, but they're not too overwhelming. We'll leave it at that. I don't want, I'll press submit just to feel the satisfaction of being told I'm right. You can do that one with the exact same property, making the base on both sides the same. But we'll stop there for our little introduction. Let me know if you have any questions. I'll end with a little blurb of what we're all about, and you have yourself a great rest of the day.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.